In this video, we are going to discuss about the physical properties of alkanes, alkenes and alkynes. Physical properties. Now, in physical properties, we will learn mainly about the boiling point, melting point, solubility and density. And these properties mainly depends on the intermolecular force of attraction. Now, let's discuss the physical properties of alkanes. So, first we are going to discuss about alkanes. We know that alkanes are non-polar molecules. They are non-polar in nature. Now, what is the reason for this? Why alkanes are non-polar molecules? This is because of the covalent nature of C single bond C and C single bond H bonds. So, these bonds are covalent in nature. And also, there is very little electronegativity difference between carbon and hydrogen. As a result, we can say that the alkanes are non-polar molecules. Now, what is the intermolecular force of attraction present in alkanes? They are the van der Waals force. So, the intermolecular force of attraction present in alkanes is van der Waals force. And we know that this van der Waals force, they depend mainly on the shape and size of molecule. And the magnitude of these van der Waals force depends on the surface area of contact between adjacent atoms. Greater the surface area, greater will be the, or stronger will be the van der Waals force of attraction. Now, let us discuss each physical property of alkane in detail. The first is the physical state. So, the first physical property is the physical state, means whether it's a solid, liquid or gas. Now, when we discuss the physical state of alkanes, now among straight chain alkanes, the first four members means C1 to C4, they are all gases. Then, from C5 to C17, there is the next 13 alkanes, they are liquids, and C18 onwards are solids. So, this is about the physical state of alkanes. Now, next let's see about the boiling point, the second physical property, B. Boiling point. Now, when we discuss the boiling point of alkanes, we can say that the boiling point of straight chain alkanes, means with no branches. Straight chain alkanes increases with increase in number of carbon atom or increase in molecular mass. So, the first point that we have to note is boiling point of straight chain alkanes increases with increase in number of carbon atom or increase in molecular mass. Okay, now what is the reason for this? Why the boiling point of alkenes increases with increase in number of carbon atom? The reason is, as the molecular size increases, number of carbon atom increases means molecular size increases, surface area increases, the magnitude of van der Waals force increases, boiling point increases. Now, the second point that has to be noted under boiling point is boiling point of branched chain alkanes. Branched chain alkanes are lower than normal alkanes. Normal alkanes means straight chain alkanes. Now, why the branched chain alkanes have lower boiling point than normal alkanes? Because we know that with branching, the surface area decreases. So, van der Waals force of attraction decreases, boiling point decreases. Now, one example for this boiling point is the boiling point of CH3, CH2, CH2. This is our normal pentane. 1, 2, 3, 4, 5 carbon atom is normal pentane. This will be greater than an isomer of pentane that will be with one branch. For example, CH3, CH, CH3, CH2, CH3. And this is our 1, 2, 3, 4. This is 2-methyl butane. You can see there is one branch in this. Now, the boiling point of this compound will be greater than CH3, C, CH3, CH3, CH3. This is a compound with 2 branches. So, as branching increases, the boiling point decreases. Now, greater the branching, lower will be the boiling point. So, these are the 2 important points that is to be noted in boiling point. Now, the third physical property is, that is C, melting point. Melting point. Now, under melting point, normal alkanes with even number of carbon atoms have high melting point than next lower normal alkane with odd number of carbon atoms. That's a very important point to be noted. That is, normal alkane with even number of carbon atom. Even number of carbon atoms have high melting point than next lower normal alkane with odd number of carbon atom. For example, the melting point of normal butane will be greater than the next lower alkane with odd number of carbon is propane. So, it will be greater than normal propane. Now, what is the reason for this variation in melting point? We know that the melting point of a substance does not depend not only on size and shape of molecule, but it also depends upon how closely the molecules are packed in crystal lattice. That is, in normal alkanes with even number of carbon atom, they are more symmetrical and is closely packed in the crystal lattice. So, we can say they have high melting point than the lower alkane with odd number of carbon atoms. So, what is the reason for the high melting point of normal alkanes with even number of carbon atom? Because due to the presence of even number of carbon atom, the close packing is, they have a symmetrical close packing arrangement. So, their melting point is also very high. Now, the next physical property is solubility. D is solubility. Now, there is a general rule of solubility, that is, like dissolves like. This is the general rule, that is, non-polar solvents or non-polar compounds are soluble in non-polar solvents. So, we know that our alkanes are non-polar in nature. So, they are soluble in non-polar solvents, and example for non-polar solvent is benzene, carbon tetrachloride. Then we have ether, another non-polar solvent. So, these alkanes are soluble in benzene, carbon tetrachloride and ether, and non-polar compounds are insoluble in polar solvents. Polar solvent means water. So, alkanes are insoluble in water, alcohol, etc., because water and alcohol are polar solvents. So, polar compounds are soluble in polar solvents and non-polar compounds will be soluble in non-polar solvents. Okay. Now, the last physical property of alkane is density. Density. We know that density is equal to mass by volume. So, as molecular mass increases, density increases. So, as size of alkanes increases, density increases. So, these are the physical properties of alkanes. Now, next let us discuss the physical property of alkenes. So, next we have the physical properties of alkenes. Now, in alkenes, about the physical state, the first 3 members are colorless gases, next 14 members are liquids, while higher ones are solids. Now, about the solubility, again these alkenes are also non-polar molecules, so they are insoluble in water, but they are soluble in non-polar solvents. Again, with regard to melting point and boiling point, all the things, all the properties are similar to that of alkenes. Boiling point, when we discuss about alkenes, we can say boiling point increases with increase in molecular mass or number of carbon atom, and if there is branching, boiling point decreases. Now, next let us discuss about the physical properties of alkynes. Alkynes. Now, regarding the physical state of alkynes, again the first 3 members are colorless gases, next 8 are liquids and higher ones are solids. Now, melting point and boiling point, that is to be noted here for alkynes. The melting point and boiling point of alkynes are slightly higher than alkanes and alkenes. Very important, that is melting point and boiling point of alkynes is higher than alkene, higher than alkane. Why? The reason is, in alkynes we have triple bond and they have a linear structure, and hence their molecules can be more closely packed in crystal lattice as compared to alkanes and alkenes. So, the melting point and boiling point of alkynes is greater than alkene, greater than alkane. Now, with regard to solubility of alkyne, they are also non-polar molecules, so they are insoluble in water but soluble in non-polar solvents. And density, as molecular mass increases, density of alkynes increases. So, when you compare the physical property of alkenes and alkynes, we can see all the physical properties are almost same. Okay. Now, the point that has to be noted is regarding the melting and boiling point of the 3 hydrocarbons. Alkyne has higher melting and boiling point than alkenes than alkenes. So, with this we complete the physical properties of alkenes, alkenes and alkynes. Thank you.